Good morning, ACT class. It's been a minute, but it's time for us to get on to the second half of our packet. I'm kind of proud of this, so I'm just going to show. This is the water balls I got for my golf team. I'm really excited about them. Unfortunately, we lost our season, but got a golf ball, water bottle, sure. Okay, anyway, so I'm going to be making sure I stay hydrated. I hope you're doing the same, staying safe and healthy. This one is the geometry review, and I realized when I pick up your packet it was huge, and I'm so sorry, but it just kind of is what it is, I guess. But remember that they double-sided it, so you're only doing the right-hand side. So I usually teach this memory technique. Supplementary is, well, I'm from Oklahoma, and after supper you go to, so this is a bed, that's a pillow, in case you can't tell my drawings, because I'm not a very good drawer. Anyways, after supper you go to sleep, right? So that's 180. So supplementary angles are 180. So like right here, these two angles are making on a straight line. So I would do something that b plus 71 equals 180. I would subtract 71 from both sides, and I'd get 109. In the same way, over here I've got b plus 147 equals 180, and when I subtract, b equals 33. And so that's supplementary angles. The next one is complementary. This is gonna prove my age here. So back when I was in school, we didn't really have computers, to be honest. I'm an 80s baby, and so the best we had was we had typing classes, but they were those huge, ginormous screen. I can't even draw a screen, but you remember, like, they were like huge. You could ask your parents. They were like huge, and they had like a big bubble at the back, and basically you had to do it on a table. So the way I used to teach it, and I haven't really found another way, is that for us to be at typing class on the computer, our knees are at 90 degrees. Complementary is 90 degrees. That's how my brain remembers. So as you can see right here, of course, we know that 40 plus 50 makes 90. And right here is kind of a mixture. It kind of depends. Some of you would see that because that's 90, this is 90, or you could see the whole thing and say that 180 minus the 90 and then minus the 55 would get me to the 35. Okay. All right, so looking right here, the rest of these, it's not like they are going to ask you to label this as alternate exterior, but it is, I don't think they would ever ask that, but in case you're curious, they're called alternate exterior because they are on alternate sides of the transversal, and they are on the exterior, meaning outside, like exterior window panels, right? That means on the outside of the house. Exterior means that they're equal. Alternate exterior are equal. You can even see that this one's acute and this one is acute, meaning less than 90. So I could put 25x plus 5 equal to 80. I would subtract 5 to get 25x equals 75, and I would divide by 25 to get x equals 3. I'm going to stop for just a second and see if you guys can try this, and you can pause it if you want. So again, we've got these alternate exterior. We got 16x plus 4 equals 180, or excuse me, 100. It's not, I got used to saying 180 because of up here, but that's equal to 100. So 16x equals 96, and then divide by 16 and x equals 6. Okay, moving on to the next page. Okay, so these two are different. They're alternate interior. We can see that. Oop, I'm gonna have to switch my other page so I don't have to do all the calculations. Again, right here, you can see that these are alternate on the transversal, but this time they're interior. I'm sure you've heard of interior design Interior means on the inside. And again, they're just equal. And again, you can see they're both acute. These look like they're slightly acute. Okay, well, but that little symbol right there, I marked it, but that's a right angle, which means 90 degrees. So 30x equals 90. When I divide by 30, x would equal 3. Again, if you want to try practice solving, you can. Otherwise, I'm going to keep going. But right here, I've got 11x plus 5 equals 12x. An important piece to know right here is that if I have x's on both sides, I want to get them together first. And since this one's all alone, I'm going to move this one over. And so 5 would equal x. Okay, change up the colors here. This time, this guy has a couple different names. You can see it on the same side. So these were alternate of the transferal. These are on the same side. So they can be called consecutive interior. They could also be called collinear because they share a line, which means that they are also supplementary. Again, you don't have to know any of this. You just have to see that one is obtuse and one is acute, so they can't be equal now, right? So again, if they're supplementary, that means they add up to 180, or they're collinear, they add up to 180. So this x and 78 and 110 now equal 180. So a lot of different things you can do. You could put these together first, but I have several students that would say, Cooper, just one at a time. And I would say, okay. This one comes out kind of weird. It comes out to a -8. Weird math. Do you want to try this one? You can pause it. So again, 37x plus 4 plus 65 equals 180. These together are 69, so I'm going to go ahead and subtract that and get 37x equals 111. And then when I divide by 37 on both sides, I get 3. Okay, this last one is the hardest for students to see, and I'm not quite sure why, but I kind of teach it like, do you remember, like I was taught never eat sour watermelon. I've been told students never eat soggy Wheaties, but I kind of think of like, this is northeast, southwest, obviously. I think of this corner, they're both in the southwest corner. So right here, this would be southeast corner. Right, they're both in that same they're called corresponding angles, and they're corresponding directions. Let's look at these. So these first ones that were equal, they were both acute, and then consecutive interior. One was obtuse, one was acute. Let's look at this one. Can you think? Obviously, you can't tell me what you think, but what do you think? Are they the same or different? You can see they are the same, so they're equal. So once again, I have this 108 plus x equals 103. Oh, so sorry. Subtract the 108, and x equals -5. Math, so weird. Again, these are equal, so I have x plus 71 equals 65. Subtract 71 from both sides, and x equals -6. Okay. So I've got to go back to my pens. This is the front side. So right here, this one is one that really gets at kids. It's called vertical angles. Vertical angles are also equal, but the tough part is they do something like this, where you're like, well, I don't know these other angles, so I can't possibly understand it. But right here, any two lines that cross will create vertical angles. So these guys are equal to these guys, and this is equal to this. So 5x plus 4 equals 39. Subtract 4, 5x equals 35. Divide by 5 and x equals 7. Oh, I got out of focus for some reason. That's weird. Okay. All right, do you want to try this one? Hopefully you did. So we've got 3x plus 2 equals 56. Subtract 2 to get 3x equals 54. Divide by 3 to get x equals 18. I am writing really fast, but I'm hoping that if you need to, you could always pause right here and write them both down, or whatever you need to do. These next ones are just review. The first one, I would assume you would all be like, Cooper, are you kidding me? Of course we know it's length times width. 7.5 times 2.8, we put in the calculator and we get 21, and I'll be fancy and say inches squared. Right, that's nothing new, so I'm sure you guys could do this if you wanted to. Or you could just keep watching and write down the answers, because that's probably where you are in life right now. This is hard, huh? None of you have emailed me and said, Cooper, I'm over it. So I'm assuming you're all still trying to get these credits, but it's hard. I get it. All right, so this is called a parallelogram. So a rectangle has opposite sides equal and 90-degree angles. A parallelogram is like a rectangle, opposite sides equal, but no 90-degree angles. But get this, it's still length times width, or some people prefer to say base times height. Same thing, 12 times 6, 72, we'll be fancy and say kilometers squared. So even though it looks like you're gonna have to like find this side and do a squared plus b squared equals c squared, you don't have to. This is the base, this is the height. So 6.3 times 5 is 31.5 centimeters squared. Okay, triangles. I personally was taught 1/2 base times height. I've heard other people say that they did base times height divided by 2. Sure, whatever you want to do. So remember that they do have to be perpendicular. So I'd have 7.7 times 2.1, and that's 8.085 centimeters squared. Do you want to try this one? All right, 11 times 7 is, oh, sorry, times 1/2. Oh, Cooper, you didn't write it in the right order. Okay, 1/2 times 11 times 7 is 38.5 meters squared. Give you a big look while I turn the page. All right, we got one more page of like formulas, and then it looks like we have some practice problems, so let's get to it. Sorry, okay. So these guys are called trapezoids. And the equation of a trapezoid, I would usually have you get out your little flashcards and work through this with me. But since we don't have that, we're just going to write it down. 1/2 base 1 plus base 2 times height. So the bases are the ones that are parallel to one another. So I would do 1/2 of 3.7 plus 10.1 times 9.1. I would strongly suggest you use that Calculate 84. Calculate 84 app on your Apple or Android. Is Android? Whatever. And so let's see if you can do it. You would say 1/2, or you could do 0.5, whatever. But you do need to put in parentheses 3.7 plus 10.1, or else you would get the order of operations incorrect. Faster way would be 0.5, 3.7 plus 10.1 times 9.1. You can see I did a lot less keystrokes, a lot less parentheses, same thing. We get 62.79 inches squared. I think you should try this. All right, again, hopefully you did. So we would do 1/2 of that 2.9 plus 9.1 times 6.9. So 0.5, 2.9 plus 9.1 times 6.9, and I get 41.4 kilometers squared. Just a little quick thing. I've only seen it on one time, but one time they did this. Do you see it's the same thing just on its side? But it would still be this equation because the bases are always the ones that are parallel to one another. Okay? All right. Let's get busy here. Midpoint, I said this is always on the test. Every single test I have taken has always had the midpoint on it, either asking you to find the midpoint or find the endpoints. This is my x1, y1, x2, y2. I label them like that because every point comes xy. This is my first point, this is my second point. So the equation for midpoint is x1 plus x2 over 2, y1 plus y2 over 2. So what I mean is I'm going to take these two x's, my negative 6 plus 2 over 2. Since I already have that color, I'm going to go ahead and do it. Negative 6 plus 2 is negative 4 over 2, which would be negative 2. Okay, then I would take my y's. Oh, that's pretty dark. Okay, so negative 6 plus 10. Sorry if you can't see that anymore. Hopefully you just are using your paper. And so 4 over 2 is 2. So this is the answer. Why don't you try a second, see if you can do this one. Might as well use the same colors. So here we go. We've got this negative 5 and negative 9. Negative 5 plus negative 9 is negative 14 over 2 is negative 7. And then right here, negative 1 and negative 6. Negative 1 plus negative 6 is negative 7 over 2. And so I would personally leave it like that. However, if you're like, Cooper, I did the calculations good, you would have negative 7 and negative 3.5. But they usually leave it in fractions. Okay, here we go. Distance. I'd say it's like every other test. Not every single test, like midpoint. Midpoint's like every single test, but distance is like every now and then. So it is x2 minus x1 squared plus y2 minus y1 squared. Okay, so again, this is my x1, y1, x2, y2. I'm gonna have to use my pen on this the whole time, not because of, it's just too hard. Distance is negative 2 minus negative 1 squared plus y2, 6 minus negative 4 squared, and all that's underneath the square root. So again, to get the square root, we hit second x squared. You see the square root, and we're going to put it all in the exact same way. If you don't wear the negative, so this is the minus, this is the negative, right? Okay, 1 squared plus 6 minus negative 4 squared. So I'm putting it in exactly like I wrote it. When I hit the answer, I get 10.4, which is what I want. I think you should try this one. Pause. Thank you. So again, distance would be x1, y1, x2, y2. Negative 2 minus 1 squared plus negative 4 minus negative 3 squared. Let's put it in square root. Negative 2 minus 1 squared plus negative 4 minus negative 3 squared is 3.16, which is what I got last year. So we're good. Or last term, I guess. Okay. The next one is, what if, it's very similar actually, it's the same equation just kind of written differently, but if I have a right angle, I can do a squared plus b squared equals c squared. I want to remind you that that c has to be the hypotenuse, which is the one across from the right angle. So in this case, I would say 10.1 squared plus 9 squared equals x squared. I would put this into my calculator. 10.1 squared plus 9 squared is 183.01 equals x squared. And the only way to get rid of a square is to do the square root. I'm going to teach you a quick hack here. You hit second square root, second negative. And then what it does is it takes that answer. So it's essentially the exact same as me typing in that exact answer. It's a good shortcut, if you like shortcuts. I do. Okay, do you want, oh, so this one, now this is my hypotenuse. So it's going to be x squared plus 5.3 squared equals 7.1 squared. Me personally, I usually just subtract the 5.3 squared. So I'm going to do 7.1 squared minus 5.3 squared is this number. And then again, I'm going to take the square root, second, square root, second, answer, and I get 4.72. Okay, last little lesson note here. This is surface area, and surface area means add all areas. So what I typically do is show you a box, which I have not in my guest bedroom. Sorry. So I hope you can see though that this is, I'm going to call this my front. But do you see it's the same as the back? So front and back are going to be the same. So I'm going to say 2 times this area. And you have to be able to see it. This is a 4 by 11. 4 by 11. So 2 times 4 times 11 is 88. So right here, I would consider this to be my left and right. Left and right. So there's 2 of them. And again, it's a 9 by 11, which would give me 198. And then I would consider this guy my top. And top and bottom would be the same. So there's 2 of them. 9 by 4, which is 72. And so to get my final answer, I would add all these together. And so I'd get 358 meters squared. Oh, I almost said cubed. But it's still squared because this is meter squared, this is meter squared, this is meter squared, and we're just adding. We're not multiplying. Okay, do you want to try this for a sec? Okay, so again, front and back, I would see is this guy. So I'd have 2 9 by 9s, which is going to be 169. Oops, sorry, front and back. I would consider this to be my left and right. And if you don't have this order, it's okay. It's just what I picked. Everyone sees this a little different, but right here that's a 9, and you should see that that's parallel to right here, so that's got to be a 6. So my left and right is 2 9 by 6s, which is going to be 108. And that's kind of cool. My top and bottom is also a 6 by 9, which is 108. And so the final would be 378 kilometers squared.